In this video, we will look at how to use PSpice to find the Thevenin voltage and Thevenin resistance. Recall that the Thevenin voltage is the open circuit voltage between the given terminals of interest, and the Thevenin resistance can be found using any of the three different methods depending upon what type of circuit elements are present in the given circuit. For circuits that contain independent sources only, or contain both independent and dependent sources, we can use PSpice to find the open circuit voltage, which is the Thevenin voltage, and we can use PSpice to find the short circuit current, which can then be used to find the Thevenin resistance. Consider this circuit here. This circuit has independent sources only. We can find the Thevenin voltage and Thevenin resistance by connecting a test current source, and this is done as follows. We connect a test current source between terminals of interest A and B. When this test current source has a value of 0 amps, so when I test is 0 amps, this corresponds to an open circuit between terminals A and B, and in that case the voltage VAB gives us the Thevenin voltage. Similarly, we can run a DC sweep for the magnitude of this test source, and when the voltage VAB is equal to 0 volts, this corresponds to a short circuit between terminals A and B. Then in that case, the test source magnitude gives us I short circuit. So after determining I short circuit and V Thevenin, we can find R Thevenin using this relationship. This is the circuit of interest constructed in PSpice. We have connected a test DC current source with a nominal magnitude of 1 amp. In order to find the Thevenin parameters, we go to Analysis, Setup, Enable DC Sweep, and then sweep the magnitude of the test current source over a range. In this case, we have chosen to sweep from -1 to 10 amps. When we simulate, we get the plot of the test source magnitude, and this is the voltage across the test source, and this voltage is equal to this voltage shown here. We can enable the cursor, and then when we look at when the value of the test source is 0 amps, then the y-axis is the open circuit voltage, which is 32 volts in this case. Also, when we find the value when the voltage is 0 volts, this corresponds to a short circuit between the terminals of interest, and then the test source magnitude, which is 4 amps, gives us the short circuit current. Using PSpice, we have shown that I short circuit is 4 amps and V Thevenin was found directly as 32 volts. Therefore, the Thevenin resistance is equal to 8 amps as expected. So this shows how to use PSpice to find the Thevenin parameters for a circuit containing independent sources only. The same approach can be used when the circuit contains both independent and dependent sources. Consider this circuit of interest, which has both independent and dependent sources. We can connect a test current source between the terminals of interest and then run a DC sweep for the magnitude of the test source to find the value of the voltage VAB when the test source magnitude is 0. and find the magnitude of the I test source when voltage VAB is equal to 0. This is the circuit of interest constructed in PSpice, and we have a test current source applied between the terminals of interest. And by running a DC sweep for the test source magnitude, we can find Thevenin and I short circuit. This is the result obtained by simulation. We can enable the cursor and then read off the value when the test source magnitude is 0 amps, and this is equal to a voltage of 8 volts. So this is Thevenin. And then we read off the magnitude of the test source when the voltage is 0, and this gives us I short circuit of 8 amps. Using PSpice, we have seen that Thevenin is 8 volts as expected, and I short circuit was 8 amps. Thus, R Thevenin is Thevenin over I short circuit, which is equal to 1 ohm as expected. So this shows how PSpice can be used to find the Thevenin voltage and resistance for a circuit containing both independent and dependent sources. Finally, consider the case when the given circuit contains dependent sources only. If the given circuit has dependent sources only, then by definition, Thevenin is equal to 0 volts, and the only task is to find the Thevenin resistance. The Thevenin resistance can be found using the test source method only for circuits that contain dependent sources. Therefore, in PSpice, we can apply a test voltage or current source and find the value of VT and IT and use that to find the Thevenin resistance. This is the given circuit of interest simulated in PSpice. Here we have chosen to apply a test current source. For a test current source, the current IT must be flowing into the terminals of interest. Here, IT has a value 1 amp, and we need to find the voltage VT. So this can be done by simulating and then enabling voltage, bias voltage and bias current display. So here we can see that VT is minus 4 volts and IT is 1 amp. Therefore, R Thevenin is minus 4 over 1, which is minus 4 ohm as expected. Using PSpice, we have shown that IT is 1 amp and VT is minus 4 volt. Therefore, R Thevenin comes out minus 4 ohm as expected. So this shows how to find the Thevenin resistance for circuits containing dependent sources only.